Hi everyone, today we're going to be looking at some applications of right triangle trig and SOHCAHTOA. Now there's two very important vocabulary words that you're going to be seeing a lot, and that's angle of elevation and angle of depression. So we're going to start off looking at two different examples to demonstrate what the angle of elevation and depression is. So on the left hand side we see this flagpole here, and I'm going to actually even add in a person here. So an angle of elevation is from your sight line and above to the top of an object. So let's suppose that our angle of elevation is 47 degrees. So it's from this person's sight line up to the top of the flagpole. And we want to solve for how tall the flagpole is. So I'm going to put an X over here. Now, just like you have been the rest of the week, we are going to use a trig function to set up an equation. So because I want to solve for the opposite side, and they give me the adjacent side is 20 feet, O and A tells me to use tangent. So my equation would be tangent of 47 equals X divided by 20. I can then multiply both sides by 20. So I get X equals 20 times tangent of 47. So now I'm going to go to my calculator, and I'm still going to be using Desmos. So 20 times tangent of 47. Again, always make sure that you're in degree mode. So I get 21.447. And it says round to the nearest integer, so this is going to be the nearest whole number. So I'm just going to round to 21. Now, notice that I have this 4 feet from below. So I'm going to actually add that to the units that we just found. So when I add that together, that tells me that the flagpole is 25 feet tall. Now looking at the example on the right. So it says, how far is the car from the foot of the building? Round to the nearest tenth. So this one we're going to use the angle of depression. So let's suppose that a person is standing at the top of the building. Now, an angle of depression is from your sight line and below. So let's say that they see this car down below at an angle of 17 degrees. This would be my angle of depression. Now, there's a few things that you can do here, but our angle of depression is actually congruent to the angle of elevation from the car up to the person. And that is because they are alternate interior angles. So if you think about it here, our sight line and the ground are going to be parallel to each other. And because I have a transversal running through two parallel lines, that tells me that these two angles are congruent, if you remember from geometry. So now that I have an angle within my triangle, I can figure out how far the car is from the foot of the building. So I'm looking for this distance down here. So again, I have the opposite side. I want to find the adjacent. So O and A, I'm using tangent again. So I would set up an equation, tangent of 17 equals opposite over adjacent. Because my unknown variable is in the denominator, I'm going to have to cross multiply. So I'm going to write tangent of 17 over 1, cross multiply. So I get X times tangent of 17 equals 40. And then divide both sides by tangent of 17. So I go to my calculator, 40 divided by tangent of 17, and we get 130.8. And again, we're using feet. Okay, we're going to try two more examples, this time that we actually have to set up. So the first one says, you are measuring the height of a Sitka spruce tree in Alaska. You stand 45 feet from the base of the tree. You measure the angle of elevation from a point on the ground to the top of the tree to be 59 degrees. What is the height of the Sitka spruce tree? So this is our question here. So I'm going to start by drawing a picture. So I have my tree. This doesn't really look like a spruce tree, but it's the best tree that I can do. And I'm going to draw my triangle here. So let's say I'm standing over here. There we go. So it says that, sorry about that. So it says you stand 45 feet from the base of the tree. So that distance goes down here. And then the angle of elevation from a point on the ground to the top of the tree is 59 degrees. And we want to figure out the height of the tree. So I'm going to put X over there. So again, I figure out which trig function I need to use. So if I'm solving for the opposite side and we have the adjacent, I'm going to use tangent again. So tangent of my angle, 59 degrees, equals X divided by 45. So you can either multiply both sides by 45 or cross multiply. You're really going to be doing the same thing. So 45 times tangent of 59. I go to my calculator. And we get 74.89. And my units are still in feet. Okay, so here's our last example. So this one says the escalator of the Wilshire, Vermont Metro Rail Station in Los Angeles rises 76 feet vertically at an angle of elevation of 30 degrees. Find the distance a person travels on the escalator stairs. Okay, so picture our escalator here. And I'm going to draw a triangle. So it says that the escalator rises 76 feet vertically. So this is going to be my vertical distance here. And it rises at an angle of elevation of 30 degrees. And we want to find the distance a person travels on the escalator stairs. Well, if you think about where the person would be, if they're going up the escalator stairs, that means I'm looking for this distance right here. So that's my hypotenuse of the triangle. So this one's going to be slightly different. So if my angle 30 degrees is the one down here, I have the opposite side and I'm solving for the hypotenuse. So opposite and hypotenuse tells me to use sine. So I would set this equation up as sine of 30 degrees equals the opposite, so 76, divided by the hypotenuse x. So again, I put sine of 30 over 1, and I cross multiply. So we get x times sine of 30 equals 76. Finally, I divide both sides by sine of 30. And we get 152.